Well, good day, everybody. Welcome to episode 012 of Code While. In this episode, I'll be sharing some examples of how to establish unique numeric identifiers for objects and functions in JavaScript, and I hope you'll enjoy it. There's a QR code at the top right of this page here, and if you care to scan that and follow the resulting link, you'll reach this same web page here where you can follow along with the same code if you like. All right. And let's see here. So, what's the first thing I've got here? All right. I've got a function inside of an expression, and I'm calling that function. And so all of this stuff inside here is going to get executed. And what does it do? There are three variables here. Well, the first thing it does is it checks whether or not this funny named property of the object.prototype object is not equal to undefined. If it's not equal to undefined, it'll return. And what is this doing? This is permitting this whole business to be invoked multiple times, but only the first time will have an impact, will make a difference. So what is this funny looking property name here? This ampersand here is a tribute to the address operator from C programming language, and an underscore to make it a little bit more obscure. Hopefully this doesn't come into conflict as a property of object.prototype with other libraries or other code from other folks. But anyway, it gets installed once and not more than once from this business here. The next thing that happens is this clean broken variable. What do we do for it? We'll make a new function via the function constructor, and its body will simply be to return broken, whatever that is, followed by a new line, followed by broken.toString. Okay, well that gives us the string representation of this function down here, broken. All it does is throw an error. But we take that string representation and that gets wrapped up inside the body of a new function. So that's what this new function expression is doing. It's basically cleaning up the scope of this broken function here. I don't know where all this business will be run. I don't know which scope it'll be run in. It could be run anywhere, and that might incorporate identifiers from other scopes higher up in the scope chain. Just to avoid that, I'm using this new function constructor to sort of clean it up. And so it's basically a copy of broken, but cleaned of other scopes and identifiers, and that's why it's called clean broken. So I invoke this function, and it returns this broken copy right here, and that gets assigned to clean broken. Moving along, new get idea is roughly the same idea, but a little bit different. Here I'm going to create a new function. This time it takes parameters, ID, new ID, and value, and it returns this getID function, which is down here. And it does that by taking the getID toString result and appending that inside this function body. Now this is going to be another sort of clean function, cleaned of other scopes and identifiers, but I'm actually going to keep this function directly as new getID. Next, it's the same idea once again for this clean new ID. I create a new function, and this time it takes parameters broken, ID, new getID, and the body is simply to return new ID, which we'll see in just a moment here. And then it follows with the new ID toString, string representation of that function. And after we get that new clean function created, I'm going to invoke it, and I'm going to pass it those three arguments. Clean broken from here will become broken inside the scope of this new function. And then the number 1 will become the ID, and the result of new getID, a function, will be the third argument here, and it'll become this new getID parameter inside this function. And all of that gets put into this clean new ID function. And that clean new ID function is then invoked upon object.prototype, and that's going to install it, as we'll see. All right, so what have we got here? Broken. That's just going to throw an error no matter what. And here's the magic here in the getID function. First we do some trivial argument checking because it's not expected to take any arguments. And what does it do here? It checks if this funny named property of this, however this is invoked, it'll have a this object. It'll check that property to find out if it's exactly equivalent to getID itself, this function. If it's not, and if there is a property with this name as a property of the this object, and if it's a function, then we will try to invoke that other function by taking it and issuing a .call and passing this as the this argument for the call. Now you might ask, why not just return this with this stuff here and then with a left and right bracket? Why use .call and pass it this? Well, that's to work around a Microsoft Internet Explorer 6 bug. Maybe I'll cover that in another episode. Maybe I won't. And if that property exists, we'll invoke that property and return its result as the result of our invocation. Otherwise, we check if this is equal to value, wherever that comes from. We don't know yet. And if it is, we'll return this ID, wherever that comes from. Otherwise, if these two are not equivalent, we'll invoke the newID function, and we'll pass it this. And so this newID function is just down here. It takes a value, and it attempts to mutate that value. It assigns this funny named property to this value, to the broken function. Then it checks to see if the ID, wherever that comes from, is equal to this number, which is a hexadecimal representation here with a 2 followed by 13 zeros. And just so you know, that's a pretty large number. If this was an address for every byte, then this would be 8 petabytes worth of addresses. That's what that's worth. 8 petabytes should be enough for anybody. So we check if that ID is equal to that maximum limit. And if it is, then we throw an error. Too many IDs. Chances are you won't run into that limit. But if it's beneath that limit, then we'll increment the ID by 1. And the next thing we'll do is we will overwrite the property that we just wrote a moment ago with the result of invoking new getID with this latest ID and with newID, this function itself, and with the value that was passed to newID. After that has been assigned to this property of the value, we'll return the ID. Okay, so that all seems pretty complicated, so let's try to explore what's going on. One of the things we could do is invoke this property directly for any object or function, but it might be nice to use a helper utility. So I've got one of those here. What does this do? This is just going to create an object called EP for episode 012, if it doesn't already exist, and it'll assign another getID function, a different getID function. And this function takes a value. Up in the previous section here, this getID function, it only ever gets invoked with a this, but no argument there. And this must always be an object of some kind, either an object or a function. But this getID takes a value, and that value can be a non-object or a non-function. And what is it doing here? It's switching the value for special casing, checking if it's undefined. If it's undefined, it returns an ID of 0. And if it's null, it returns an ID of 1. Otherwise, it'll invoke object.prototype with that funny named property via a call technique, and it will pass it the value that was passed to getID. All right, that's what that does. And let's see it in action here. Let's just double check that it works for undefined. It should return a 0. Okay, it does. And for null, it should return a 1. And it does. Okay, moving along here. The first generated ID actually belongs to object prototype. That was assigned up in the first section there. So I'm going to try it out. Object.prototype. I'm going to get that funny name property. I'm going to call it. And it establishes an ID of 2, or recalls it. And the helper, since it invokes the object.prototype with that funny name property, it's also going to invoke the same thing. It should return the same result, and it does too. All right. Don't confuse object.prototype with object. Object is a different object than object.prototype. So even though object is going to have this same property because it's inherited from object.prototype, it's not going to give the same result here. So object itself now has an ID of 3 that was just generated. And if we pass this, that's going to be either the global object or the window object, depending on whether you're in a web browser or not. So I'm going to issue that, and we get an ID of 4. All right. Moving along, one thing to remember is that if you use object.prototype and this property and use the .call technique to invoke any function, if you pass either undefined or null as this argument, then outside of strict mode, which is a modern feature of modern JavaScript, outside of strict mode, it's going to be either the global or the window object. So this should yield the same result as the previous example. And it does, ID 4. All right. Moving along here, primitive values get temporary objects when you invoke the identifier function with them. So here's false. I'm going to get its inherited property. I'm going to invoke that. Same with the number 0 and this decimal number here with some decimal digits after the decimal point, and with not a number, and with negative infinity, and with a string. I'm going to try to get IDs for all of those, and I'm just going to display the results here. Okay, they each got different IDs, 5 through 10, all right. And if I do it again, though, those objects were temporary. They had nothing to do with the actual values here. They were sort of wrapped up with an object just for the sake of satisfying this identification code. So if I issue it all again with all the same code here, they're going to have different identifiers, 11 through 16 this time. All right. And what can we do here? As I just mentioned, all of these got wrapped up with objects, so we can do that manually by using the object constructor and passing it a primitive value. And so I'm going to assign that to this sumNan object, and that's what I get. That object can have an ID, as happened previously, and this time it's going to be 17. That's the next one in the sequence, and that ID will persist for that object because I'm not creating a new object for nan. I've got an object for nan. I'm going to check that object again and should still say 17. It does. All right. And here I'm going to make 3 objects. No big deal. I didn't say all right that time. This time I'm going to look at the ID for the foo object, which was just created. And it gets ID 18. Well, what happens if we copy that property from foo to bar, which hasn't been populated yet? I'm going to do that here. Now, if we invoke that property for bar, you might expect that it would yield the result 18, but it doesn't. That's what the sorcery of the original section is all about, to avoid that kind of situation. So if I invoke it on bar, I get a new ID, 19, even though this property was copied from foo. If we remove or replace that property on foo, we will get a new ID for foo. So here I'm deleting that property and then trying to re-invoke it again. It's going to be inherited from object.prototype, and it won't find the previous instance, so it's going to generate a new ID, ID 20. Here I'm going to link those 3 demo objects in a circle. Foo.next will point towards bar, bar.next will point towards baz, and baz.next will point all the way back to foo. So they'll be in a circle here. I've done that. Now here I'm going to show a example of why you might want to use a unique numeric identifier for objects and functions. One of the use cases is keeping track of visited items. So I'm going to try to visit all of these nodes, but I don't want to spin in a loop forever by visiting them over and over again. So I'm going to track which ones I've visited using unique identifiers here. How does this work? All right, inside here, 4 variables: count of visited, ID, obj, and visited. And I'm going to initialize count of visited to 0. Visited is going to be an empty object, and it's going to have properties which are going to be the unique identifiers of the objects that are visited. I'm going to start with obj being assigned to the foo object, and in the condition of this for loop, I'm going to check if obj is not a falsy value, and if it isn't, the next iteration will reassign obj to be the obj.next, so it'll follow the chain of links here. And for each iteration, the first thing I do is I check the ID of the object, and I store that into ID. Then I check if that ID is a truthy property of the visited object, and if it is, I'm going to break out of the for loop with the assumption that there's a cycle, and we don't want an infinite loop, so we have to break out of cycles. Otherwise, I'll increment the count of visited by 1, and then I will add that ID for that object as a property of the visited object, and I'll set it to true so that it's detected if it should ever be visited again. And after that loop is terminated, I'll return the count of visited. And what did it do? It detected 3 objects, not infinity. All right, another use case is for reference counting. How does this work here? Okay, I'm going to add to the episode 012 object, I'm going to make a reference counts object and a retain function. And retain just takes an object argument. And what does it do? It fetches the ID of the value, and then it checks if the type of that ID as a property of the reference counts object is undefined. We're going to assume that's 0 and intentionally set it to be 0. Next, I'll check if the count of references is equal to that same giant number. That's a useful ceiling. And if it is, I'm going to throw an error. There are too many references to that object. Otherwise, I'm going to increment the count of references for this object by its ID. And if it was undefined before, it will at least be 0 because of this check right here. And then I'll simply return the count of references that was just incremented. Down here in release, it's almost an exact opposite of what was above there. Get the ID, check if it doesn't exist. If it doesn't exist already, I will throw an error that somebody has tried more releases than there were retains. And after that, I'll decrement the reference count for that ID, and then I will fetch that count. And then if it's 0, I'm going to actually clean up a little bit more and actually remove that property with that identifier from the reference counts object, just to save a slot, clean up a slot. All right, let's see it in action here. Retain a few times. Here I've issued retain on the foo object for the foo object 4 times, and it gives me the retention count of 4. Oops, I'm having some misclicks today here. I'll release it the same number of times, 4 times. I should get a 0. So that's working. Those are 2 use cases for why you might want to use identifiers. Generally, it's kind of like any time that you'd want some metadata or some secondary data to be associated with particular data, but you don't want to pollute the original data or store that secondary data in the same record or the same object, then this is a sort of a minimal touch of the object just to establish an index so that you can refer to it in another band, so to speak. You might consider it a sort of a columnar mindset, where you don't pack everything into one record, but you do use an index or an identifier to establish relationships between data and associations for conceptually related material or subjects. So that's why you might want to use a unique index here. Now, one warning is to be careful of leaks. Here I'm going to issue retain on an empty object. This object isn't identified by anything. So after this line has executed, we'll never be able to access this object again because it's sort of anonymous. And I just happen to know from counting that its identifier would be 22. So let's see what happens if we issue this. Here the reference count got to 1, but we'll never be able to release it because we can't refer to the same object to issue a release call for. So be careful of leaks. Also be careful of using submitted text in property names. So here's a very contrived example. It's not specific to this particular utility function that's the subject of this episode, but in general, you should avoid situations in which you take user-submitted text and use it in properties unwisely. So here I've got some unwise code where here's some user-submitted text. Apples and friends have been submitted by this victim, and they've been given the opportunity to choose a function that gets executed when their particular text has been submitted. And after that user has made their decisions, going to issue a retain on that victim. So there's going to be an ID for this object, and it's going to have a retention count incremented to 1. But then a hacker joins later on. The hacker has their own object, and they've added a hello and chosen the speech function to be the response for their hello text. And similarly to above, that hacker's account will have a retention count of 1. But then here's the hack. The hacker adds another property with this utility name. This could really be any function name, commonly found function name, and there would be great risk. And it so happens that they were able to choose this contrived 23 function, which returns 23, which happens to be the ID for this victim. So after that happens, the hacker simply deletes their account. Some code somewhere ends up releasing the hacker their account, but it's going to do so by checking this ID property and calling it and getting the result. And that result is 23, and that refers to the victim. So the hacker deleting their account results in the victim's account becoming deleted. So the victim's deleted, and I'll check the reference counts for the ID of the victim. And here we see that it's undefined. So the deletion affected the victim. So what else here? Modern JavaScript has tons of features. Some are getters and setters and freezing, object.freeze. These can all interfere with this approach that this episode has been demonstrating here. So what happens here? I'm going to make a log that's an empty array, a surprise object. I'm going to freeze that surprise object. Then I'm going to push onto the logs the ID of the surprise object 3 times just to find out what happens. Then I'll join the logs with a new line and return the result. And we see here that because the object was frozen before this ID was invoked on the object, it results in a different ID each time, which is not desirable. So that's one way things can be a little mixed up. And, I've clicked too many times here. I've got to click through this again here. I'm really having some muscle control for my fingers today. Boy, oh boy, let's get back to where we were here. Okay. Earlier I'd mentioned that strict mode permitted this to be undefined and null. So let's check that out here. I'm going to redo this whole utility function, but this time I'm going to have a slight difference here. It's going to have useStrict appear in this getID function, and then it's going to have that switch that we saw earlier in the external getID function, it's going to be hard-coded inside here. It's going to switch this undefined, it'll return 0, null, it'll return 1. And what else is different here? Anything? No, I think that's it. Okay, so now we'll redo the same test as earlier. We'll call this new version of the utility function on undefined, and instead of referring to the global or window object, this will actually pass undefined. So it should actually return 0 because it'll compare for equivalence with this case here in this switch statement. So this time we get a 0 directly from that property. And for null, we'll get 1. And after that, there is a memory cost for using a closure like this code does. Thinking about it in terms of the C programming language, perhaps, roughly speaking, we might expect that in the object that has the property, we'll need memory for a slot for the property. A slot could be a node in a linked list. In the object, we'd also need a pointer into all the property names because it's got that funny 2-character name. And in the list of property names, there could be a slot for that particular property name entry. That's a one-time cost though. And then in the list of property names, a pointer in that slot to point to that property name in the list of all known strings. Then in the list of strings, there needs to be a slot. Then in the list of strings, there needs to be a pointer in that slot to the Unicode bytes. And that should all be a one-time cost for that particular property name. That's okay. But in the object, we also need a pointer into all known functions because there's a particular function being referenced for that property name. In the function, it's going to have a pointer into all known function images. So of all the different kinds of images, there's going to be one function image for all of those getID, internal getID functions. They'll all have the same image. And then in the list of function images, that image itself will be stored somewhere, some representation of how that function behaves. And then in the function, there will be a property structure because the function itself, a closure, a function, they can have properties like objects can have properties. So there needs to be all this properties structure just like all objects have for it. In the function, it'll also have a pointer into its particular scope, which identifiers are available when that particular instance of that function executes. In the list of scopes, there'll need to be a slot for that scope. And in that scope, there'll need to be a pointer to the parent scope, which was established way earlier when we used the function constructor. And the parent scope, that was a one-time cost for that function constructor. And in the scope, there will be a list of variables, and in the scope, there will be a list of values for those variables. That's a lot going on, but it's not particular to this code's example. This is the case for all closures that you might store as properties anywhere. So half of it can be roughly said to be for storing the closure as a property, and the other half you could roughly say is for the closure being unique to all other closures or functions. All right, well, I hope you enjoyed that, and I hope it's useful to you. I know it's been handy to me in the past, and this particular version of it will be handy in some future episodes. So have a pleasant day, and I hope you'll join in again. Take care.